In this video, we're going to be talking about Chapter 10, Polynomials, from the Cumulative Review exercises from the OpenStax 2nd edition pre-algebra textbook. Starting with problem number 77, 8m squared plus 12m minus 5 minus the quantity 2m squared minus 7m minus 1. We're going to distribute this negative over the parentheses. 8m squared plus 12m minus 5 minus 2m squared plus 7m plus 1. I'm going to collect my like terms together so that I'm going to get the m squareds together, and that's going to be 8 minus 2m squared. You get 12 plus 7m, and I'm going to get negative 5 plus 1 as my constants. So 8 minus 2 is going to be 6m squared. 12 plus 7 is going to give me 19m, and negative 5 plus 1 is going to give me a negative 4. Adding a negative 4 is the same as subtracting 4, and that's my simplified polynomial. Problem number 78 asks us to multiply p to the third times p to the 10th. So remember our rules of exponents: when we multiply like bases, we add the exponents. And our next problem asks us to raise a power to a power. So that's going to be y to the fourth raised to the third. And raise a power to a power, we multiply the exponents. It's going to be y to the 12th. Same idea going on with the next one, only we've got a numerical coefficient inside as well. So we're going to have to raise 3 to the third, and a to the fifth gets raised to the third. So we're going to multiply that times that exponent times 3. 3 to the third is something we can simplify, though, is 27, and we will. That's going to be a to the 15th. Moving right along now to number 81, I have x to the third raised to the fifth, x squared raised to the third. So we're going to do our multiplication before we do our addition. This is going to be x to the 15th times x to the 6th. And I add 15 and 6, I get 21. For number 82, we have 2/3 m to the third n to the 6th times 1/6 m to the fourth n to the fourth. I'm going to take the 2 goes into the 6 3 times. 1/3 times 1/3 is going to be 1/9. M to the 3 plus 4 is 7. And to the 6 plus 4 is 10. So 1/9 m to the 7th, n to the 10th. Number 83 asks us to multiply two binomials, y minus 4 times y plus 12. You may know the acronym FOIL, which tells us to multiply the first, outside, inside, and last, but I'm going to show you how to do this so that when we get to 85, it'll make sense. This is a y times the y plus 12, and a negative 4 times the y plus 12. So now I'm going to double distribute here. This is going to be y squared plus 12y minus 4y minus 48. These are like terms in the middle that are going to combine to give me positive 8y. And usually you're going to multiply the two binomials and end up with a trinomial. Not always, but usually that's how it works. Let's try the FOIL method here with 3c plus 1 times 9c minus 4. So when we FOIL, we get 3 times 9 is 27, c squared. 3c times negative 4 is negative 12c. 1 times 9 is going to be 9c. 1 times negative 4 is negative 4. Combine those like terms that are in the middle is going to give you negative 3c minus 4. So this is the FOIL method down here. First, outside, inside, last. Clear all this. Now, we can't FOIL when we have x minus 1 times x squared minus 3x minus 2 because we don't have two terms and two terms. FOIL only works with a binomial times a binomial. So instead, we're going to have to use the first technique that I showed you, where I write x outside of the first set of parentheses and negative 1 outside of this set of parentheses. There we go. And you may have learned the rainbow method is what your teachers may have called it in school, where we're just going to distribute over everything on the inside. That's okay. This is, multiple distributions, but I'm going to show you the distributions here this way, so it's easier for you to see x times x squared is x cubed, because when we're multiplying like bases, we're adding the exponents. Again, we're raising the exponent on x here by 1. 1 plus 1 is 2. There were 0 x's here. Add 1 to it is going to be a negative 2x. This is going to be minus x squared. I'm going to line the like terms up, plus 3x plus 2. This just makes it easier for me to add my like terms now. Negative 3 minus 1 is negative 4. 3 minus 2 is 1. There's my final answer. That was number 85. Moving on to number 86, it asks us what 8x raised to the 0 power is. As long as x is not equal to 0, which we're assuming that it's not here, we're going to say anything raised to the 0 power is going to be 1. That's just a rule. Anything to the 0 power is 1, as long as that anything that's being raised to the 0 power is not 0. Anything to the first power is itself. So the reason for that is that if I am going to take anything to the first power as itself, and I'm going to divide anything by itself, any non-zero number divided by itself is 1, and 1 minus 1 in the exponent spot is going to give me 0 in the exponent spot. Okay. Let's try number 87, which puts some of these things together. X to the third raised to the fifth over x squared to the fourth. We're now dividing like bases, so we're going to subtract exponents. We're going to get x to the 15th in the numerator, x to the 8th in the denominator is going to be x to the 15 minus 8. It's going to be x to the 7th. Number 88 asks us what 32, a to the 7th, b to the 2nd, divided by 12, a to the 3rd, b to the 6th is. So I'm going to look for common factors here. 4 goes into 32 8 times, 4 goes into 12 3 times. So this is going to be 8/3. A to the 7 minus 3 is 4. B, let me write that in the numerator. There's more b's in the denominator, so I'm going to subtract 6. I'm going to subtract 2 from 6. 6 minus 2 is going to be 4. So I'm going to put those 4 b's in the denominator because I'm subtracting 2 from 6. This is 6 minus 2. This was 7 minus 3. I always subtract smaller number from bigger number because I want positive exponents when I'm done. All right. Next one asking what a, b to the negative third, a to the negative third, b to the sixes. We haven't really talked about negative exponents yet, but negative exponents are going to bring it across the fraction bar. We just used negative exponents a long time ago in history because we wanted to write everything on one line and not waste paper when paper was expensive. It's kind of an antiquated thing. We use fractions now, and that's okay. 1 plus a negative 3 is going to be a negative 2. A negative 3 plus 6 is going to be a positive 3. So we're going to keep that b to the third in the numerator, remove that a to the negative second across the fraction bar, and make the exponent positive. When you take it across the fraction bar, change the sign. We're going to write our answer with only positive exponents. All right, number 90, we're going to write some numbers in scientific notation. So we're going to write one number to the left of the decimal point, one non-zero number. This is going to be 4.8 times 10 to the 3, and 3 is 6 because I want to put the decimal point right here, and to move that 1, 2, 3, 4, 5, 6 places to the right. 3 and 3 is 6, so that's where I get that from. Our second one, we're going to have 6.37 times 10 to the, now I'm going to have to move this one to the left because I'm putting it right there with the 6. I have to move it back 1, 2, 3. So that's going to be a negative 3. All right. Last problem in this section, we're going to find the greatest common factor of the trinomial. 3x to the fourth minus 6x to the third minus 18x squared. I'm going to look at the numerical part first. 3, 6, and 18 all have a common factor of 3, so I'm going to pull a 3 out. The lowest power on x that I see in everything is going to be x squared. So we're going to divide 3x to the fourth by 3x squared. We're going to have x squared left. Then we're going to have negative 6x to the third divided by 3x squared is going to give us a negative 2x. And negative 18x squared divided by 3x squared is going to give us a negative 6. We can factor the polynomial a little bit more now. Tells us to factor it completely. So 3x squared. This trinomial is going to factor into two binomials. X times x gives us x squared. The signs are different because we get a negative product when we multiply the last terms. Factors of 6 that have a difference of 2. Ooh, can we factor that anymore? I don't think we can. Let's prove that we can't factor that anymore. If that had been a 1, we would have been in really good shape, but we don't know factors of 6 that have a difference of 2. Let's prove to you that there are none. Okay, so let's make a list here. Factors of 6 are going to be 1 and 6. Now I would want the bigger one to be negative here since the inside term is negative. We have 2 and negative 3. So we're going to look at the sum of these to add up to the middle. This would add to be negative 5. This would add to be negative 1. I see that negative 2 is in between there and I haven't missed any factor pairs. So this part is prime, right? So just wanted to make sure that we couldn't factor that polynomial anymore, and we cannot. All right, we'll do some more with some factoring later on and different factoring techniques. Great. That is the end of it for this video. Next time we're going to come back and we're going to talk about graphing linear equations.